In today's lesson, I'll be teaching you how to solve for angles using SOHCAHTOA. As a heads up, guys, there will be a quiz on Monday. It will cover the lessons from all this week. So Pythagorean theorem, trig ratios, solving for sides, and solving for angles, today's lesson. So please make sure you catch up and keep up so that you can complete those assignments because you will have a test next Friday. So first thing today, if you have not done Tuesday's or Thursday's assignment, you need to make sure that you understand what we have learned so far about using right triangle trig. And then you will go to Delta Math and complete today's assignment, which is solving for angles. Watch the video, and for the first part of the notes, if you click here, and you have the capability to print, or if you'd like to go ahead and pause it and copy this down, we're going to be filling this in on the first part of the note. So you can go to print if you're able to do so. All right, so you are going to submit a picture of those notes, so that chart plus your work from problems 1 through 15. However, I am doing 1 through 16, or 1 through 6 rather, in the video. It's a pretty easy lesson today. So make sure you have your phone calculator handy or your TI graphing calculator. All right, so just setting up here to get ready. Here are your 15 problems. 1 through 6, again, I'm going to work out. And I have gone ahead and copied the triangles on paper. So if you wanted to pause after I go over this and do that, you're welcome to, or pause while I'm going over the video. All right, so let me focus it a little bit so you can see better. So it says finding a missing angle with a trig ratio. With trigonometry, you only need to know two sides in order to find an angle in a right triangle. Let me do that for you. You only need to know two sides in order to find an angle in a right triangle. So you need to be writing all of this down, everything up here, if you're unable to print, okay? So first you will decide how two given sides relate to the missing angle. And on the Delta Math practice problems, that means we're going to be using x for our angle measure. Then, similar to what we did in the previous lesson, we will set up a trig equation using the appropriate trig ratio. So, of course, important to remember is sine is opposite over hypotenuse, and no, we cannot flip that upside down. It has to be the opposite on top and the hypotenuse on the bottom. SOHCAHTOA. And if you're like, what is that? That means you haven't done the previous two assignments. So you need to pause this video and go back and learn that. All right. What will be different this time is we will have to use the inverse trig ratio in our calculator to produce an angle measurement. So let me kind of give you a heads up. So on our calculator, in the previous lesson, you learned to use, let me focus it a little bit, the sine, cosine, and tangent button. All right, so we use sine, cosine, and tangent when we're solving for an angle measure. Recall that the first thing I asked you to do was go to mode and change it to degree mode. So tap degree and make sure you press enter. If you have a TI graphing calculator, you would do the same thing. Move it to degree and then press the enter button. Okay, you have to hit enter. So we are finding angle measures, and remember, angle measures are going to be certainly no more than 180, but all these angle measures will be less than 90 degrees. So somewhere between 0 and 90, less than 90 degrees. Okay, so once we're in this mode, if you notice above sine and cosine and tangent, I'm zooming in, sorry, please forgive me while I try to make sure you can see this. I'm going to hit zoom. All right. So what you should notice is above sine and cosine and tangent, you see what looks like sine to the -1, cosine to the -1, and tangent to the -1. They really aren't to the -1. That to the -1 power is what we call inverse. And in fact, in Math 3, you'll learn a lot more about inverse functions. But really what I need you to think is about inverse operations. So remember, the inverse of adding is to subtract. When we are finding the angle measure, the inverse of finding a side would be to find the angle. So we are going to be hitting, to access these blue sine, cosine, and inverse tangent buttons, we're going to need to hit the blue second button first. But I'll walk through that in just a moment. So just wanted to kind of highlight that while we were using sine, cosine, and tangent, we will be using inverse sine, inverse cosine, and inverse tangent for these, okay? So things we should already know. We already know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what does it mean to find the inverse? It means to find the angle will be equal to, for sine, if we are given the opposite and hypotenuse of the angle, and notice here they have sine of this symbol called theta. And theta is just a Greek letter to represent the angle, okay? So in place of this, we've used like sine of A or sine of B, etc. But remember that this is an angle measure. So to find the angle measure, because we don't know it, we're actually going to hit second sine or inverse sine of our opposite over hypotenuse. So it's still so and ka and toa. The only difference is when we are finding the angle, we have to hit second cosine or second sine or second tangent. And of course, cosine is what? Adjacent over hypotenuse still. So ka. And then if we know the opposite and adjacent of the angle x, then we're going to hit inverse tangent of opposite over adjacent. So it's still toa. Okay? That's our so, ka, and toa. So, ka, toa still applies. The only difference is we're going to use the inverse, okay? Now, what does that mean in calculator keys? I already showed you on your calculator that second sine means that sine inverse button. Second cosine is your cosine inverse button. And second tan is your inverse tangent button. So, for example, let's say we were to set up a ratio, and like I told you, we were going to use x here. So say we're trying to find the sine of x. So sine of x, and we set it up, and the opposite over hypotenuse is 1 over 2. Then, in fact, what we are going to do is on our calculator, I'm going to try to make it where you can see both my calculator, my steps, and what I'm writing on paper. Move this over, sorry. All right, hopefully that'll work. So I'm going to hit second sine. So second sine, and notice it looks like, I'm sorry, I'm trying to make sure you can see it. So second sine, looks like I have the decimal there. Second sine of 1 divided by 2. Then that would give us 30 degrees. If, let's say, for some reason we had a decimal value, and that might come from doing the adjacent divided by the hypotenuse number, and we got a decimal. So we would hit second cosine of 0.7498, and that would be about 41.4 degrees. And sometimes we can get square roots for sides. Remember when we did like the hypotenuse, and sometimes or Pythagorean theorem, and sometimes we had radicals. So whatever that ratio is, it's opposite over adjacent. We're just going to hit second tangent of this ratio. Square root 19. Then I'm going to get out of the radical and hit divided by 3. And that would be about 55.5 degrees. So notice I'm rounding all of these numbers to the 10th place unless they're an integer. and I'm putting the degree symbol as my unit. So how is that going to apply for what we're doing today? So again, let me focus this, and if you want to take a screenshot or something because you missed something, or just like to have it in your phone as reference, you will need to submit a picture of this with the problems that you work out today. Even if you printed it out, just take a picture of what you printed out and filled in, or if you hand wrote it. So I just wanted you to be able to take a picture or whatever if you needed, or screenshot. So I've already written out the 6 problems from the Delta Math assignment that I'm going to do with you. You are welcome to, if you want, pause the video and just draw the figures from 1 through 6, or you can just pause the video as I go along and then fill in the work, okay? So here, notice again, all of these are right triangles. Our trig only works for right triangles here, right triangle trig. So we have a 90-degree measure. We have this angle up here that we're given an x, meaning our job is to solve for that angle. What is that angle measure? And we're given these 2 sides. So similar to yesterday, you are still going to go, okay, what do we call these 2 sides? No, that's show up very well. I'm going to use the orange. So what do we call these 2 sides in relation to x? We always know that the side opposite the right angle is the hypotenuse, and if this side is next to the angle, it will be the adjacent. So because we used A and H, and remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So keep that at the top of your page. That way, when you see A and H, you can look up here and go, oh, A and H, I have to use cosine. So that means that if I set up my regular ratio like we did for sides, that cosine of x, because that's my angle, it's always cosine of your angle, sine of your angle, tangent of your angle. We just don't know it, right? So cosine of x is equal to adjacent over hypotenuse. So my adjacent is 1.5, my hypotenuse is 7.5. So the question is, how do I solve? This is where you go to your chart, okay? So remember, the only difference is really we're doing calculator steps. So this means if I know that the cosine of my angle is adjacent over hypotenuse, then how do I find my value? I do second cosine. So that means that x, and I'm going to ask you to write exactly what you type in your calculator. We are going to do inverse cosine of 1.5 over 7.5. So if you write the ratio, cosine x equals 1.5 over 7.5, just like we've been doing, then to solve, x will be equal to the inverse cosine of this same ratio. So now I'm just going to take my calculator. Might not see it very well, but I don't want to keep readjusting. So second cosine 1.5 divided by 7.5. So maybe you can see that. Cosine, so I get about 78.5. So my angle x is approximately 78.5 degrees. I am rounding to the 10th because on the Delta Math assignment, the instructions are going to be to round, oh, actually, this one says to the nearest degree. They may say to the nearest 10th. So if it says to the nearest degree, let me back that up. If they say to the nearest degree, and I have, I'm going to really make sure you can see it. And if I have 78.46, if we are not rounding to the 10th, we do not look at this 6, we look at the 4. So if this 4 is less than 5, then we are going to round down to 78. So this is going to be approximately 78 degrees, since it said to the nearest degree. Okay, so keep that in mind. If I'm rounding to the nearest degree, I only want to look at the one number after the decimal, and since it's less than 5, I'm not going to round up. I'm going to round down. Now, if you look at number 2, the instructions say find the measure of angle I, but round it to the nearest 10th of a degree. So it will be important for you to pay attention to those instructions. So for number 2, again, I've already drawn it. Feel free to pause the video so you can copy the problem first. So I'm going to label these two sides where I have numbers so I can determine what are they in relation to x. So again, like I didn't use a stick person on number 1, but from this perspective, how do we label these two sides? Well, this side over here is the hypotenuse, but do not put an h because there's nothing there that's going to help us. So this 5.3 is next to the angle, so that is our adjacent side. The side way over here, not connected to the angle, is the opposite. So since I used O and A, that tells me to use which trig ratio? O and A is TOA, tangent. So that means the tangent of x, so always of your angle, tangent x equals opposite over adjacent. But that means when I solve, I need to use, you guessed it, inverse tangent. So I'm just writing down exactly what my calculator steps are. So calc steps. This means I'm going to hit second tangent and then type this in. So second tangent of 2.1 divided by 5.3 gives me 21.6. So x is approximately 21.6 degrees. Remember, you have to be in degree mode. So if you're not getting these values and you're typing it in just like me, make sure you're going back and pressing mode and making sure it's on degree mode. Tap that degree and make sure you hit enter. Once you change it one time, it'll stay that way. But if your phone maybe cuts off or the app shuts, then you may need to redo that. So 21.6 for number 2. All right. And number 3, I'm going to read the instructions. This says I'm to find the measure of angle J, so this x value, to the nearest degree. So I'm rounding to a whole number this time. So for number 3, again, I'm going to highlight the two sides that I'm given because I only want to label these two sides. 99 is the hypotenuse. Way over here from this angle x is the opposite. Oh, I used O and H. So that tells me to use sine. So that means sine of my angle is equal to opposite over hypotenuse. But that means, again, when I'm solving, how am I going to type that in my calculator? I'm going to do the inverse operation to get x by itself, so inverse sine of my opposite over hypotenuse. And that's how I'll type it in. Second sine, 58 over 99. So I get approximately, and it said to the nearest degree. So if I've got 35.8, then that 8 is going to make my 5 round up. So that's going to be 36 degrees. All right. So I've done a sine, cosine, and tangent for 1 through 3. 4, 5, and 6 are also another sine, cosine, and tangent. If you feel confident that you can do this assignment and you would like to just stop the video and move on and do those, just go ahead and do the remaining 15 problems, you're welcome to do so. If you would like to hear me explain more, then continue to listen. So sorry I had some bleed through here. But again, I'm going to, for number 4, again, if you want to stop the video so you can copy the problem, then do that. So I'm going to go ahead and label these sides. Next to my angle is the adjacent. Way over here, not attached to this angle, is 4.1, so that's my opposite. So SOHCAHTOA tells me to use tangent. So tangent x equals opposite, always opposite on top, always adjacent on the bottom. It has to be TOA, okay? So again, what am I going to type in my calculator to solve? The inverse operation would be tangent inverse of 4.1 over 1.8. So second tangent, 4.1 over 1.8. And let's see what they asked us to round to here. For number 4, it says to the nearest degree. So that's the nearest whole number. So if I'm looking at 66.2, because that 2 is less than 5, I round down to 66 degrees. So it's approximately 66 degrees. Next, for number 5, again, if you need to pause to copy this down, you can do so. If you'd also like to pause it, try it yourself, then resume the video to check your answer, that would be a good thing as well. So kind of let this video be interactive for you. I'm again highlighting the 2 sides for which I have numbers. We are not going to highlight and label any side that does not have information to help us, okay? So in relation to x, again, way over here, not connected to the angle, is the opposite. And again, this diagonal side opposite the right angle is our hypotenuse. So now we have O and H. So that's so, or sine. So sine of x equals opposite over hypotenuse. And then how do I find the value of x? In my calculator, I do inverse sine. So again, you can always just go back to here and go, oh, okay, I wrote the sine ratio. I know it's sine. How do I type it in? So that's inverse sine of my opposite over hypotenuse. I hit second sine to get my answer. Okay, so let this chart help you if need be. So inverse sine of 2.9 over 6.6. And I might need to check and see what they want us to round to for number 5. Let's see. Up to the nearest degree. Maybe I already asked it or looked at it and forgot. So I'm going to hit second sine of 2.9 divided by 6.6. Sorry. Inverse sine 2.9 divided by 6.6. And it says to the nearest degree, so that's about 26 degrees. 26 degrees. So I hope this is starting to feel very comfortable for you. In the next couple of lessons, we're really just going to be learning to apply trig ratios to some application problems. So here we go with number 6. Number 6, we are asked to round to the nearest tenth. So I'm going to go ahead and highlight these 2 sides. Sorry, I hit the focus button. Highlighting the 2 sides with numbers. And then I'm going to designate them as either hypotenuse, adjacent, or opposite. So this side is my hypotenuse. This side is next to my angle, so it is the adjacent side. So A and H, so ka, ah. So I'm going to use cosine. So cosine of my angle is equal to adjacent ka over hypotenuse. So 1.2 over 5.7. But then think, oh, what do I type in my calculator? I type in second cosine or cosine inverse of this same adjacent over hypotenuse fraction. And it said round to the nearest tenth, right? Is that right? I forget. To the nearest tenth. All right, so I'm going to hit second cosine of 1.2 over 5.7. Try to get where you can see it good. There we go. It's not too bad. So to the nearest tenth of a degree would be, if I look at the 4, 4 does not make the 8 round up because it is less than 5, so I'm going to round to 77.8. One of the most common mistakes I see students do is they'll say, oh, the 6 makes the 4 round up to a 5, and so if it rounds up to a 5, then it rounds this 8 up to a 9. That is not the case. When it says round to the 10th, we never look past the 4, okay? If it is 5 or less than 5 rather, this 4 is going to make that 8 stay an 8, okay? So 77.8, and we'll be done with this video, and then your job will be to go and complete the remaining problems. So I've done 6 for you. You'll finish 7 through 15. When you submit your work, we should see exactly what you have here. We should see this. Let me focus it. Just trying to be clear so you understand what you have to submit. You need to submit the notes from here and the work, which should look like this, from all 15 problems, okay? So make sure you are drawing the triangle. We want to see it labeled. We want to see your ratio. And we want to see what you type in your calculator. All right, good luck.